Alright, hello again, grade 10s. We are today studying the last type of form for your linear equations. So we've done two forms already, slope y-intercept form, which is y equals mx plus b. We did yesterday the slope point form, or last lesson, which is y minus y1 equals slope times x minus x1. And today we're going to do general form. You know what? I'm going to take a sticky note and just summarize those really quickly. And I would say that the first two were very user-friendly, but today's is not very user-friendly. Unfortunately, it's pretty common. Okay? So there's your three forms. Y equals mx plus b form. That's slope y-intercept form. Here's slope point form, and here's general form that we're going to do today at the bottom here. So the beautiful thing about the first two types are they give you two major hints. First one, they give you slope, and then the y-intercept. Awesome. That's major, because once you have your y-intercept, whatever it is, you can apply the slope to it. So your y-intercept is going to be, 0 comma something. And then once you start there, you apply your slope, your rise over run to it. Super easy to graph, super easy formula to work with. Well, the next form, same thing. It tells you slope and a random point. Don't forget the random point. You have to flip the values of the x1 and your y1, but again, it gives you a random point on the graph already to start with, and then you apply your slope as well. Well, for this one, there's no hints at all given. So we're very sad about this. You don't know what the slope is, you don't know what any of the points are, you don't know the intercepts, so you have to do work yourself to find the slope or find a point on the graph. The good news is it's very easy to convert this guy back into y equals mx plus b form, the form that we like. All you got to do, if you think about it, is isolate your y. You got to get your y alone, move everything else to the other side of the equation, and then you're back into that. So that's one of the major skills we're going to learn, how to get it out of this ugly general form, back into that. Alright, so as I said, here's general form. A few things I want to mention about them is they give you no hints, so no slope, no intercepts, no nothing. And notice that for it to be in general form, all terms, your x term, your y term, and your constant are going to be on the same side of the equation. There are going to be no fractions, so the a, the b, and the c, the numbers, are never allowed to be fractions. They have to be whole numbers, or integers, I should say. And then you try to keep your x value positive. So if you're deciding, because your a, b, and c can be on this side of the equation or on the other side of the equation, how do you kind of decide? Well, you usually try to keep your x value positive. Okay, that will tell you which side to go on, to the left side or the right side. So the first skill we're going to do is how to convert to general form, which is, in my eyes, is kind of a useless skill, but every textbook, every resource I've ever had always asks this. Even though you'd never want to turn it into a form that you like into the general form, I don't know why you'd ever want to do this. It's still a good algebraic skill to practice. So practicing your algebra, okay? So to convert to general form for the first one, I want to move everything to the same side of the equation. That means I could dump everything, these two terms, onto the left, or move my y on the right. And it sounds easier to move my y on the right, but do you remember I said I try to keep my x positive? So I'm actually going to move the 2 over 3x, the negative 2 over 3x to the other side, and the 4 to the left side as well. So you do that by doing the opposite operations. I'm going to add 2 over 3x to both sides, and I'm also going to minus 4 to both sides. That will wipe everything on the right side. Sorry, it looks a little messy. That will wipe everything on the right side out. But remember, I added 2 over 3x over here, and the y was already over there, the positive y, the plus y, and I minused 4. So long story short, if you want to do an easy, not so messy way of this, is just, change the sign. When you move this x over here, it's going to be positive 2 over 3x. And when you move the 4 over there, it's going to be minus 4. The y stays put. So there's your equation almost in general form, but we're not allowed fractions. How do you get rid of this divided by 3? So there's 4 kind of terms here. You would multiply everything here by 3 to wipe out that divided by 3. So you need to multiply the 0 by 3, that negative 4 by 3, the y, and that. So multiply everything by 3, and if you do that properly, going back to your polynomial unit, you'll get 2x plus, oopsies, that's supposed to be plus 3y minus 12 equals 0. You're even technically multiplying the 0 by 3. So notice I just tripled everything. So now I'm in general form. Again, that doesn't help you because it, Everything is on the same side. Your x is positive. There's no fractions, but it doesn't help you graph this because it's all, back to no hints. All right, if it's slope point form, the other form we just studied, you first would FOIL this out. We did that last lesson too. So that's going to give you a 3 over 5x plus a 6 over 5, kind of ugly. And then we got to do the same thing. We got to move everything to the same side of the equation and then get rid of the fractions. So I'm actually going to move everything to the right side this time because I want to, my x is already positive, 3 over 5x. I want to keep it positive. So I'm going to do the opposite, which is minus a y and plus a 1 from both sides. Minus a y and plus a 1. And actually the 6 over 5 and the 1 are really like terms, so you're going to have to add those together. So the left side totally cancels out. The right side has your 3 over 5x. Your minus y would go next, no like term with that. But the 6 over 5 and the 1, both are like terms, right? They're both just numbers alone. They're constants. So would you agree 1 is the same as 5 over 5, right? So it's really 6 over 5 plus 5 over 5. Let's cross that out. And that would give you 11 over 5. Okay. But now we have two terms that are both, fractions. We need to multiply this whole thing by 5 to get rid of that. So the 0 by 5, every single term, all 4 terms, multiply them by 5. So it's still going to be 0 equals 3x minus 5y plus 11. Now we're in general form. By the way, if you ever get a question where there's two different denominators, let's say one was something over 2 and something over 5, you have to get rid of 2 fractions. Well, you would multiply by the lowest common multiple. So if you're trying to get rid of something over 2 and something over 5, if you multiply the whole thing by 10, it will actually wipe out both of those denominators. So you multiply by the lowest common denominator if they ever give you a question like that. Okay, cool. So that's kind of, in a way, not very helpful because, I don't know, you don't really want general form. Instead, the second example, and if you're following along with the textbook, that was kind of the work they did on page 379. On page 380, they actually ask you to graph something that's in general form right there. 3x plus 2y minus 18. So I just copied that. And really there are two methods. The book shows one way. So I'm trying to graph something in general form here. And there are two methods. Method number 1 is a method we learned in another lesson, another skill. Well, we know this is a linear equation because it's degree 1, right? We know it's a straight line. So if it's a straight line, we just got to get 2 points. You could, method 1, get the x-intercept and the y-intercept. Do you remember how to do that? You look at your equation and you set the opposite value to 0. So for the x-intercept, we're going to make y 0. And for the y-intercept, we're going to make x 0. So the opposite one goes to 0. So we're going to substitute those in and find your two intercepts, and then if you just join those 2 points together, well, you've graphed the line. And that, I believe, is the method that they did in the book. Yes, it is. So let's follow along with them. So for my x-intercept, I make my y value 0. So notice that where it was 2y, I put 2 times 0. And I'm going to solve for my x now. So 2 times 0 can kind of just be 0 still, so it wipes out. And now you have to solve your x, so get it alone. Add 18 to the other side, and x is almost alone now. So 3x equals positive 18 now. Now you have to divide by 3, and what's, on both sides of course, what's 18 divided by 3? It's 6. So your 1 point is 6, 0. So you could graph that point on a graph, and let's figure out the other one. This time you're going to make the opposite one, x equal to 0. So 3 times x would be 3 times 0. Plus 2y minus 18 equals 0. So 3 times 0 cancels out. You just have 2y minus 18 equals 0. And same strategy. Now you're solving for your y, so add 18 to both sides. You get 2y is 18. And when you divide by 2, y equals 9. So you have your other point. It's 0, 9. Don't forget the 0 goes in different places. Here we set y to 0. And this time we set x to 0. So one of them is 6, 0, one of them is 0, 9. You could graph those 2 points now and connect them, and you've graphed this thing. That's what they did over here. So notice in the textbook, they have their 6, 0, and their 0, 9. They just join them together. Boom. You've got this graph. So that's a very good method, but I think a very important skill is, especially since I just told you, you can tell, I personally don't love general form, so I love this method. Why not turn it into y equals mx plus b form? And again, that's a good practice of your algebra skills. All you have to do is get the y alone. So if I'm starting with 3x plus 2y minus 18 equals 0, I'm trying to get this y alone. Okay? So I need to move this 18, negative 18, and the 3x to the other side to try to isolate my y. So you could do them one at a time. I'm going to do them both at the same time. I know I'm going to minus 3x. I'm going to plus 18 to wipe those out. But of course do it to this side too. Minus the 3x and plus 18. So that's easy. Right now I've now got 2y still left over on the left hand side. And now negative 3x and plus 18. If you're kind of a visual person, all you're going to do to get your y alone is move the other two terms to the other side and of course switch their sign. So it becomes a negative 3x and a positive 18. Alright? So we've got that. Now we have to divide everything by 2. So there's 3 terms. I'm going to divide that by 2. Divide that by 2, divide that by 2. So that cancels out. You just have y alone now. And guess what? Negative 3 over 2x. There's your y equals mx. And then the plus b, 18 divided by 2 is 9. So there's your y equals mx plus b form. So I like that because that's always easy to graph. You would start with your y-intercept on the graph. Again, that's 0, 9. That's that same point we got earlier when we did the other method. So you'd graph that point, 0, 9, and then you would simply apply your slope, which is negative 3 over 2. That means you go down 3, right 2, and you find your next point. So you go down 3, right 2, down 3, right 2, down 3, right 2, and you can graph that way. So personally, I would recommend getting good at method number 2, converting general form to y equals mx plus b. Basically, get your y alone, you move the other two terms, and then you divide by whatever the coefficient is, and you're always going to have your y equals mx plus b form. Get good at that, because that's going to be very helpful. That's just a really good skill to have in your arsenal. Just a review, something we did before. How do you test if a point is actually on your graph? Okay, so we already have this one graphed, so it's fresh in our minds. I'll just talk about it now. So you know how this y equals negative 3 over 2x plus 9 that we just got would graph to look like this one in the textbook on page 380, right here, right? How do you ever test a point to see if a random point actually would fall on your line? It's called satisfying the equation. So let's test a point we clearly know is not on this graph, like 2, 1, right? 2, 1 is clearly not on this equation, right? That point falls off of this line. So how would I test this point 2, 1? Well, I have an x value and a y value. All you have to do is plug the x in for the x of your equation, the y into the y of your equation, those two numbers. There's no variables anymore to solve, and just do the calculation, see if the left side equals the right side, if they match. If they match, what that means is the point is on your line. So clearly this one shouldn't match. Now watch what happens when we substitute that in there. So 1 goes in for the y, equals negative 3 over 2. 2 goes in for the x. And we're just going to solve the right-hand side and left-hand side. Nothing to solve on the left. But when you multiply this, the 2's cancel out. So negative 3 plus 9. You get 1 equals 6. 1 equals 6. The left-hand side does not match the right-hand side. This point is clearly not on our graph, but we already knew that. What happens if I test a point that actually is on the graph? Like, for example, 4, 3. That one looks like it's on the graph. Okay, so let's watch what happens when we test a point we know is on there. So 4, 3 is clearly on there. So you put your 3 in for your y, and you got your negative 3 over 2. Your x is a 4 plus 9. Okay, cool. So we're going to see if the left-hand side matches the right-hand side. This is going to give you a negative 12 over 2, which is just negative 6. And negative 6 plus 9 is 3. So 3 equals 3. So the left-hand side matches the right-hand side. We see clearly 4, 3 satisfies this equation. That means it's on that line. Cool. So I just want to throw that in there as a bit of a review skill.